All right, with that, we'll go into our next presentation. We have Rick Anderson. Rick began his career with the Florida Forest Service, then DOF, as a ranger in Pasco County. Since then, he has worked in a variety of fire management positions across the country, culminating with the position of fire management officer at Everglades National Park. I've known Rick for a while now, and his take on fire is both artful and thoughtful, and his conversations surrounding it are pretty infectious. So Rick is here today to provide us some ideas on fire effects monitoring.
Thank you, Chris. It's good to see y'all. I look out in this group here, and I've got many old colleagues, friends, and certainly a mentor or two out there that have followed your career. Chris gave a brief introduction of kind of my biography with fire. I worked in 8 national parks, but I really got my start in fire management with my family. I learned to burn from my ancestors here in Florida. I'm very proud of the fire culture we have in Florida as I do my work and travel across the world, and especially be in this room with folks who have, it's kind of baked in our Southern DNA to use fire. And also appreciate y'all that aren't from the South that somehow joined the cult that we have here and picked up on this, because there's really no place like Florida for fire. And I'll give you a good example of that. I travel a lot now in my work. Most of my work is internationally in the south of our border, deep into South America, Central America. And I was flying back from Arizona recently, and I was sitting next to a woman on the plane. And as we got into the South, it was February, and you started seeing smoke columns right about Louisiana popping up. And as we made that transact, we busted over the top of the Gulf, I saw a nice fire. It looked like it was arcing over the top of Pensacola and into the Gulf. And she looked at me, and she's obviously a businesswoman, been traveling quite a bit. And she said, you know what's weird about Florida? And I thought, oh no, not this conversation. She said, this time of year when I fly into Florida, the clouds are coming out of the ground. That was my opportunity to talk like Greg provoked us about prescribed fire. But I don't know if you've had that awkward moment where, how do I explain what we do to someone who believes the clouds come out of the ground? So I'll leave that alone right now. This talk, it's anybody, when you looked at the agenda, saw fire effects monitoring and did kind of a face palm and go, oh God. Well, I hope you didn't, but we're going to go there. My consulting firm is Fuegos Fire Management. Again, I mentioned I work mostly for United Nations, the Forest Service International Program, the government of Germany, and also Japan and a few other funders to work with mostly cultures that are using fire. One of the things that's unique about our part of the world in the United States and Canada is we have a cavalry to come. We have organized fire in a way that most countries don't. It's really up to the communities in a lot of places. But one of the things in this talk, part of it I'm going to mean to be provocative, in so much as I want you to think a little bit differently, kind of bend the way you think about fire a little bit. And I'll give you some good examples. And we heard this morning from our meteorologist, and we heard from Greg, not only is fire changing, but some of the fire science is changing. And one of the other projects I do in the United States, I work for an integrated research management team. And I will tell you, some of our old fire science that we've been hanging on to for decades is starting to be flipped over on its head. And like Greg mentioned, and also some of the subtleties that came out in the meteorology talk, is that some of the old things is collapsing and it doesn't work anymore. For example, there's this clunky course called S390 fire behavior course. We started running some of the numbers in that course and realized that for decades we've been teaching a course with the wrong answers. Yikes. So in other words, we can do better without being too editorial about this. But often we hear this term good fire, bad fire, and that's kind of an artificial thing to say. In a lot of ways, it depends. So I'm going to talk a little bit about how to get at maybe some answers with good fire. But before I get into that, I want to, because we're from the South and for storytelling culture, sometimes I love the way Forrest Gump does business in terms of the personal narrative. But during World War II, in the Pacific Islands, there were a lot of uncontacted cultures out there living on those islands. They'd never seen a lot of the Western world. And one of the things that when the military soldiers started being delivered or arriving on these islands, of course, they needed support. And the islanders, what they would see regularly is planes fly over and release these cargo parachute cargo in to support these soldiers. They were full of food. They were full of supplies and tools and things like that. And one of the things that started happening in the South Pacific Islands is they started kind of misunderstanding the whole underpinnings of where all this stuff was coming from. So after the soldiers left and all these supplies left, all the food left, a cult developed. That all you had to do was build something that looked like an airplane, and that would summon the gods that would start dropping all these foods and supplies and things like that. And this cult became a charismatic cult. They became the leaders, but the stuff never came. And the reason why I use the stretch metaphor is that often in fire management, there's a lot of ideas out there. If we build a certain ecosystem, if we follow a certain recipe for fire management, that we'll get these gifts of biodiversity and fuels management and reduce fire, hazardous fire, and some of these more simple things. I'll leave this alone for now, and so we'll move on. One of the things that, much of the work I do is bridging science and management. And it was mentioned before, sometimes there's a big gap between academia or research and what we actually do in the field. And part of this integrated research management team I've been working on, we get they got a fancy word called co-production, which what we do is we put practitioners besides researchers in the field. When we did a recent burn on Fort Stewart in the longleaf ecosystem, we had 90 researchers and we had practitioners from Department of Defense side by side with them, really starting to have that conversation is what you really need. And because I work with a pretty good handful of researchers, I want to ask you all, who in this audience has read at least one peer-reviewed scientific journal article this year? Please raise your hand. I'm not trying to shame anybody. So a handful of you, that warms our collective hearts, because where sometimes with prescribed fire, we don't have the ability to get our message out there. Sometimes that bridge between science and management, and also, is it really practical? But again, I'm telling you, from smoke management to fire behavior, things are on the precipice of change. Along those lines, here's our old friend Smokey Bear, the shirtless mammal, doing a lot of some math. And if we look closely, this is a beautiful painting by a fellow named Wendelin back in the 50s. And if you look at that system, one message could be fire is bad. But for all of us who know that snags sometimes host a heck of a lot of biodiversity out there, and that humans actually manipulate these ecosystems. And if you look at some of these animals in the foreground, most of them are what they would call fire adapted and fire dependent species. On the second slide here, this is one of the things I dug out of the Florida Forest Service's archives. There was a time where we believed that fire reduced the productivity of longleaf pine. Has that changed? Significantly. And here's a few publications from the old days that significantly shaped many of our thinking about fire. I think one of the authors of one of these is in the room. And did anyone ever wonder like some of the concepts of strip ignition patterns and things like that start showing up? Right here in a guide for prescribed fire in the Southern Forest. Very silviculturally based thinking at that time. These are valuable publications, but also in some ways we've moved past these. Has anyone read this special little paper from 1958? Keach Biome Drought Index. We heard that earlier, KBDI. It's kind of, sometimes it's like a tyrant with prescribed fire. The KBDI is skewed. It's not. What does it take to calculate KBDI? And does anyone in this room calculate KBDI? One of the details of it that we often overlook is right in this first paragraph, which you can't see. The moisture content of the upper soil. Anybody burning on sand hills or ridges or sandy soils? This would, you need, if you read further in this paper, you need 8 inches of well-developed soil. Many of the ecosystems that I work with, particularly what was provoked when I was in the Everglades, I live in was working in a seasonally inundated wetland. And also in the Yucatan, where I do a lot of my work, it's coral rock. In other words, places that don't have well-developed soil. And in Florida Peninsula, some of the best soil is in the same places where you had the most agriculture during the plantation days and all of that. As you drop down the Florida Peninsula, things change considerably when it comes to soil. Here's my colleague Blaine Hyman from the Nature Conservancy, and I started in 2012, started looking at a very simple thing. And this is a color-coded graph, and I'll just explain to you what it is. It's an angstrom index. Believe it or not, and this is one of the advantages that I've been able to acquire from working in an international audience, the United States is not the only place thinking about fire on the planet. And this is an angstrom index developed by the Swedes. And we saw in our weather presentation earlier this morning, that color code, once you start dropping down the probability of fire. Well, a lot of the planet, especially once you get into the so-called the developing countries, is they don't have the same amount of science we do. As a matter of fact, they almost have none. So what we started doing is looking at what were the metrics that predicted a highly likely fire day, similar to what KBDI does, or at least difficulty in control. And we found some really simple metrics. And plus we have the advantage of looking at MODIS satellite imagery and spatial mapping from satellites. And one of the things we found is temperature and humidity become very predictable. And as you get higher temperatures, lower humidity, surprise to this audience, you get fires become more difficult to control. And also in a lot of the countries I work with, we use this to set our prescription criteria. Because if we're starting to drift into the pink and red zone, those are no-go days. We have reliable probability ignition, which means spotting, difficulty in control, and severe fire effects. A lot of some of the thinking that we see is simply, let's get the acres. I work for a federal agency like Chris shared in the introduction. And towards the end of my career, it was driven by acres. That was the only metric we have. And of course, at Everglades, we could punch out 10 to 50. Our burn units were about 10 to 15,000 acres apiece. It's just not fair when you have other places, maybe a Merritt Island or other places that 20 acres really freaking matters. But the idea was if we burn it, they will come. Not dissimilar to the cargo cult thinking. You know, these magical things will happen if we just burn it. And even with some audiences, it gets even more specific if we just burn it at the right time of year. And that starts getting our ideas about good fire and bad fire. With fire, what are its site-specific effects? We love to promote fire, and we should, because especially well-tended prescribed fires that we understand the effects of fire. But let's not kid ourselves. There's winners and losers out there. The way we light a particular patch matters. For all of us who are mimicking natural fire regimes, whatever that means, since when did we have strip ignition and the effects of strip ignition? There are all kind of good reasons to use strip ignition. I understand that. It keeps fire in the box. But remember, every time we ignite a site, there are creatures living in. Strip ignition sometimes, especially when we're doing aerial ignition, it can be rough on species. And who in this room does a grid after your burn to look at the winners and losers out there? We rarely do. We have to confess that there's things happening out there that we don't truly understand. We know this, all of you, and a lot of the indigenous people I work with, particularly in Brazil and Central America, the Maya, they think about fire slightly different. It's almost magical that we can take an ignition source and take a vegetation type and completely convert it to another and sometimes more productive type of effect. In other words, fire effects really matter. Why should we monitor the effects of fire? Some of you can already natively answer this question. To learn, to verify and refine our prescriptions. Who's running off the same prescriptions that you inherited from your previous fire managers? What are you laughing at, Parks? You're acknowledging, okay. Sorry to call you out. To evaluate assumptions. Greg compelled us to think about the world has changed. How is it changing? A lot of this is keeping our fingers on the pulse of ecosystems as climate change, as conditions change, and even seasonal weather events changes. And especially to ensure we do no harm, or at least the least amount of harm possible. And also, we'll always answer critics. When I was on a type 1 team with Mr. Derwachter back there, we'd roll into fire camp at the end of the day, and the community would have those cardboard signs that said, "Thank you, firefighters." Anybody rolled into Crawfordville or someplace like that and had a sign, "Thank you, prescribed burners." If you do, let me know. I want to see that sign. And also, back to earlier talk, to facilitate useful research, useful italicized and underlined research, and to share with others. We have a promise. We have to develop well-developed goals and objectives. That's the craft of fire. And also, I'll remind you, and I think Mr. Sadler will remind you as well, these are legal documents when we're doing prescribed burn plans. Do they mean anything? Are they vague? Restore fire to ecosystems. Well, I wasn't aware that they hadn't met yet. Fire knows, ecosystems know fire. And how do you know these are solid objectives? And how you know you're doing the right thing? Here's some examples of goals and objectives. That's a mix right there. Are any one of these a true objective? If I gave you a drip torch and said, go to this unit and make this happen, could you do it? Maybe, but it wouldn't have much precision. Burn a record amount of acres for our agency. I think we can do better. Mimic lightning fires with strip ignition. I'll leave that alone. And also one of the little lazy things, which I've committed this, burn in a mosaic pattern. What is that? Why? Is it beneficial? Is it really the thing to do? Or is it just say, well, we kind of burned it, patchy. You can see him starting to get snarky here. I'll leave it alone.
Yeah.
One of the things that we can do better is have specific, measurable, attainable, and time-oriented objectives. If we want to produce specific flowering events, or if we want to enhance the habitat for red-cockaded woodpecker, bobwhite quail, you name it. How much, how many, how often, and within what time period? Because we know, for example, in the Southeast Coastal Plain, we're on fast forward with things rebounding after fire. One of the takeaways from this slide is that there's a few that when you have specific objectives and when you have a burn crew, they know exactly what you're trying to pull off, or at least a pretty good idea. We want to reduce scorch height, or we want to induce scorch height. We want to punch holes in the canopy, all of those type of things. What size are those holes? That's going to have the operational people dialed in, as they say, into things that we can actually do. And I often review, because I was what they call a type 1 burn pause, I do, as a consultant, review complex burn plans. And one of the things that I see that managers and burn plan creators are challenged with is the prescription they use will not necessarily get their outcomes. I see Greg nodding, is that, you know, anyone been taught to make a wide prescription? I can tell you, unfortunately, I've been involved as a subject matter expert and have to do testimony and inquiries because I've made my share of mistakes. And investigators and attorneys can exploit these wide prescriptions really easily. Anybody got 7.2 flame links on your behave outcomes for your, are you guys really that good? You can create a 7.2 flame links. I hope you see where I'm going with that. And also it helps to the public and to anybody looking from the outside in, what are your intentions? Here's what I would call a pretty good objective, and you see why. Reduce fine fuels by 50% is measured immediately post-burn. You got a time on it. And also, if you're talking about mosaic patterns, this might get you that mosaic pattern. And also remember, these objectives are a guess. We don't operate with a high level of precision often. Limit flame links less than 1 meter. I work in the other world where we do meters. Because one of the places, we'll do a case study in a minute, where seedling mortality is really important. We want to grow a specific species of pine. So if I gave you a drip torch, would you be able to pull this off? Depending on conditions, I think you could do that. There's this concept called adaptive management. You're probably already doing this. This is kind of a fancy academic way to look at that. But we all have to develop these objectives. We have to plan. In other words, we have to do something. And some of you may be getting involved in ecosystems that you don't know a lot, or in your inheriting fuel types that you may not know a lot. But some of you are also repeatedly burning the same thing over and over. And you may want different outcomes in the future. And then monitor the effects. And then we analyze the data, even if that data is a photo point. We share our learning, and then we find our objectives, and we do it again. As I'm speaking to what I assume is an extremely skilled audience and has put a lot of fire on the ground, I'll also just try to attempt to compel you to keep bringing your game up. Let's get better at this as we change, as things change on us, and as we get more and more constraints in what we're doing. I'm going to give you a little case study here from another part of the world. We could call this pyrotourism, but in embedded in this particular case study is an opportunity to start thinking your way through some of the things that, in other words, try to bring it home to yourself, even though it's another place. This is Paynes Creek National Park. It's pine woodlands and savannas. It's on the Caribbean coast in Belize, Central America. Gosh, Greg, we were there, what, 20 years ago,
Yeah.
starting this out. So, some of you might be familiar. This is mangrove, and this is Caribbean pine savanna. It's very similar to our world here in the Southeast Coastal Plain. That's one of the reasons why I wanted to use that. This Belizean pine savanna is Caribbean pine, wiregrass, and palmetto. If you squint your eyes, it looks familiar, I hope. And just as a little side note, the British, when they left in 1981, they kind of cleaned the house in terms of the bank account, timber, mahogany, all of this stuff. But they left a few old trees, and we took some increment cores from this particular stand of Caribbean pine. Anybody care to guess how old they are? 620 to 650 years old. It's hard for these pines to get that old because termites get into the base. But so that means that they were there before the Spanish and when the Maya were using this as a travel route. So they've seen a lot. And also it might be difficult to see, that's palmetto there, our old friend. It's always about a bird, isn't it? In these old growth pines, they need the yellow-headed parrot, which is a threatened endangered species, mostly because the pet trade come in the United States and the rest of the world. Some of you might recognize that box on the outside of the tree. RCW. Yeah. Where'd we steal that idea, Michael Keyes? We didn't have enough large diameter pines because the British harvested their share. But we wanted the species to persist. Somebody had the bright idea that somebody in a specific national forest, starting with an A, in this part of the world was doing something similar with a woodpecker. And I tell you folks, it worked. Downside is the poachers know what those boxes mean. Get about $200 for each one US for each one of those chicks. That's about a month's wage. So the good thing is the rangers are able to be vigilant and keep an eye on these things. And also this technique is spread throughout the savannas of in the range of this throughout Belize and into Honduras and Nicaragua. This is our study site, Deep River Forest Preserve, Paynes Creek National Park. Forest Reserve is just like a national forest, a national park, and it's very similar to this. It's way down south near the Guatemala border. They had management goals. They were brought to the United States and went to some prescribed burn classes here from a well-meaning NGO, international NGO, and look at some to restore the management plan is to restore uneven age stands of Caribbean pines and enhance the nesting environment. Because what was happening was too frequent fire. It's very different. Too frequent fire was happening, and just they don't have the little grassy longleaf stages. So they were knocking off the regeneration. In other words, we weren't able to grow the next generation of Caribbean pine into a size that was harvestable, because at the forest reserve they need to harvest, and it wasn't developing habitat. And the other one that's related to prescribed burning, monitor and evaluate the reduction of fuel load and mitigate hardwood encroachment. One of the things that they learned when they came to Florida was that you need some hot fire to get rid of those oaks and those water oaks and stuff like that. They translated that to their activities in Belize. They believed that high intensity fire was necessary to remove shrubs that were competing with pine. That was the working assumption. We realized there's we weren't getting the pine recruitment with that type of fire regime. Lighting the head fires, backing off the encroachment from the broadleaf forest in the savannas wasn't working. What to do? We started monitoring. And one of the things that's different there, we got the community members, because it's the community members that are lighting the fires. National parks, for example, are managed by communities, not a national park service like it is here. The government, the Belizean Forest Department believes, hey, it's the people setting the fire, that's their problem, not ours. What a very different way to think about that. And you can't see this, but this little, the Caribbean pine seedling looks like a freaking loblolly. What kind of evolutionary strategy is that to look like a wispy little loblolly in wiregrass that deep? So it was, provided a big puzzle to us. We started using these old traditional plots. These are 50 by 20 meter Whitaker plots. We had the community members out there measuring not only the char marks, the fire effects, and those kind of things, and doing something that I would encourage all of you to do is photo monitoring. It's easy to do. You all got a camera, and you can start detecting change over time. And the other thing it does, and this was our hope for the future, was to maybe stimulate academic researchers to come take a look at what we weren't able to figure out through our monitoring program. We got the community members to develop the protocols with us because they had something at stake, whether it was the future of the timber operation or a number of other things, like they harvested palmetto berries. Again, sound familiar? Remember the days when they were harvesting palmetto berries here? And if you notice right here, there was a yellow-headed parrot visiting. We're making data sheets there at that point, since there's no copy machine in that region. And here were some of our monitoring questions. Are there management methods to manage fuels to diminish the negative impacts of this selective variable? In other words, pine regeneration. We weren't trying to monitor everything in the world. We had very specific things that we cared about because you can go overly deep in the monitoring world, and we don't have that much time. I acknowledge that. Photo points in a variable or two works well. We put in 14 plots in this particular ecosystem in 4 different pine density categories. And one of the things that we started seeing, and this is just a little graph, it was the shrubs, counterintuitive what we had learned in Florida. It was the shrubs that were providing the shelter for these pine seedlings. Anybody care to guess why? Knowing what you know about fire behavior. Bingo. And the fire, the mosaic pattern wasn't reaching that. But often there were several sites where they burnt it during a very dry type of year, punched in, and we were getting high levels of seedling mortality. In other words, wow, our assumptions changed. Just like Sasha says, shrub cover likely raises the ambient temperature, and there are fire types that are harmful for the production of pine seedlings. In other words, flame lengths greater than 3 feet. So we marched through the adaptive management process. And again, the level of sophistication with the people I'm working with, they're highly sophisticated in some ways, but they don't have necessarily the academic backgrounds that we have. They have good field sensibilities. They know their fire. And also they have something at stake. They live on the land that they're burning. And they live off the land that they're burning. Here's what we found out. And we were able to attract researchers and ended up publishing a paper that had influences on the way fire is managed in the savannas of that country, which happens to be the place where most fires occur, not in the broadleaf forests, the jungles, and that kind of thing. At least you know, this is one of the local fellows, the protected area manager. I believe Raylene Crandall had a heck of a time doing a talk here not too long ago, and Jen Phil from the University of Florida. So we got Florida people down there and adjusted their lens a little bit and were able to publish a paper. This is one of 5 papers published on fire ecology and fire effects in Belize right now. I want to jump into a slightly different topic, and it's very much related to some of the things that we heard today, is that monitoring is starting to jump to a whole other level. Carrying rebar in the field, doing plots, all of that is starting to spent most of my life and career doing this, collecting data. But now they can put this little thing on a tripod, anybody doing LiDAR monitoring at this point? It's becoming very, very easy to do. You put it on the tripod, you turn it on, and it can characterize large areas with great detail. And we're bringing this to Belize and Central America. And one of the reasons why we're doing that, many of you, when you look at a prescribed burn, particularly test fire, the black ash versus white ash ratio, what does that tell you when you have more white ash on your test fire? More complete consumption. It might, if you're doing your test fire at about 9 o'clock in the morning, you got white ash, 3 o'clock in the afternoon might be a wee bit challenging. That's one metric that I eyeball, and probably many of you do too. But there's something else going on. Anybody guess what's going on in terms of carbon at that point? Volatilization, more effective combustion. It's putting it up in the atmosphere. And savannas are one of the big contributors to CO2 and greenhouse gases and emissions on the planet. African savannas, Australian savannas, Central American and South American savannas, and elsewhere, grasslands are putting a lot of dirt up in the air. But one of the things that we found through our work with the UN, particularly in Australia, is where we started this, is that black ash does a little better job at sequestering carbon, and also it reduces emissions into the air. So one of the things that we're starting to do in Belize is this doesn't happen much in the United States, much at all, but we can sell carbon credit to the European Union and others. We just need good data to be able to do that. And so it's a way of getting income more valuable than forestry, more valuable than tourism, and it might have some contributions to the atmosphere and the planet as well. So that's one of the things that we're doing. We're going to be doing with LiDAR beginning in May here. And we can take a very complete picture, and we can, where we had, 14 plots, we can do several hundred in just a few days. A big game changer. You know, we got the tiered sampling. Most of you know this little image in the middle. If you can see it, standard forestry plot. And we do this machine learning is able to get us the vegetation level layers. In other words, almost all the data that we get from the tedious, and one of the things that we learned is that 2 different teams goes out to do a plot with a brown transect, and they get different data. Just human error. These laser scanners, they don't have that error. And I want to talk briefly about the Eastern Innovation Landscape Network. And again, it ties into some of the information we got in our previous talks. Is the West, a lot of research has been tilted to the western part of the United States. And we have our fair share in the Southeast coastal plain. But what, especially the Department of Defense, is getting into the research game big time. And they've seen the limitations of our experiment stations, the Forest Service and others. And what they've done is they're starting to pour research and resources into managing their land. For those of us who have been on DoD lands, some of the most ecologically intact ecosystems are on DoD lands. And it's not their number one objective. Their number one objective is usually a training mission. But what are they up to on these patches of land they have? They're blowing stuff up. they're setting fire. But they had to get into the business like all federal agencies. They had kind of ignored the Endangered Species Act for a little too long. And like many of us, sometimes litigation pushes us into a place where we're doing the right thing. Long story short, they've got, well, we know most of our a good chunk of our federal budget does go to the Department of Defense, and they're heavily committed to doing research, particularly in the United States. So I'm back to Greg's map of like from New Jersey all the way down to Florida. We have a site here at Merritt Island and sites through Georgia all the way up to New Jersey right now. And they're mostly on DoD lands, some of our own national forest lands. But one of the things that just blew my mind as an old fire dog was this right here, this Burn Pro Plus. Have anyone you've seen this? Essentially, you can look at, after your LiDAR scans, you take a good look at your patch of woods, you can put your drip torch on your map and game out your prescribed fire on your desktop and game out all the scenarios, all the weather patterns that are common to that area using National Weather Service data and others. Greg, you got any other comments about that you saw with this?
I thought it was really good particularly for people who are going to go into a site and, many of us have pyrotourists who would come down from someplace else who don't know the fuel, but they're going to spend, the PFTC 20 days, and to have the ability for them to give them a piece of property, let them see this and run through it. And we could actually put together a bunch of different weather patterns for them and then let them, that's the way that I think a lot of good training is going to go forward.
Also, for those of us that are in consultant world, it's when we plan our burns, we can show the landowner, we can show others what some of the potential outcomes are. And if things go badly, it's solid science data. In other words, it helps us do a defensible job. So I believe I've run my time here to the end. Okay. But so let's revisit cargo cult thinking here. Maybe I've flogged this metaphor a little too hard, but I'll keep trying. When we imitate behaviors without understanding how they work in the hope of achieving the same results, it's not something that works. And I would encourage you to be aware of cargo cult thinking. I would encourage you to go more on probably what you're already doing natively, and that's adaptive management. Because when I introduced myself, I shared that I learned to burn from my ancestors. I learned to burn from my grandfather. I just burned with Chris with my 86-year-old mother, who's been burning since she was old enough to throw a match on the ground. Where did you learn to burn? And just because I have that heritage doesn't put me in any special place, but because that Florida is gone. It's not coming back. We're not going back to 1491, folks. That landscape is gone. We're not even going to be able to restore the CO2 levels for us that are in the business of restoration ecology, again, whatever that means. So I'd encourage you to think about, let's move this forward. Let's take the brilliance in this old school knowledge that you have, this brilliant science that come up, and I see these young faces in the room. I'm hoping you're speaking next fire council instead of some of these old gray dogs up here, because we need you. And I'll leave you at this quotation from the Holy Book. And so proud of y'all. Keep doing what you're doing, but let's think forward. Thank you very much.